This is page 2 of Applications of Integration, HL Addendum, number 21. Sketch the graph of y equals 1 over the square root of 1 minus x squared. Just to give you a really accurate picture of what it looks like, I did it on the calculator, okay? And the reason why it's going up in this direction, it kind of stops here, is because at x equals 1 and x equals negative 1, as you can see, when you put 1 or negative 1 in to x, you're going to get 1 minus 1 on the bottom, which is 0. 1 over 0 is infinity. So as you can see, there is an asymptote at x equals negative 1 and an asymptote at x equals 1. So it kind of looks like this. The y-intercept happens to be 1, because if you put x equals 0 in here, you get 1 over 1, which is 1. Okay? So explain algebraically why the function is symmetrical about the y-axis. Well, think about it. If I put negative x in for x instead of x, do you see how I would still get the exact same function, 1 minus negative x quantity squared in the bottom? I would still get 1 minus x squared, right? So actually, when you can put negative x into the function and it comes out to be the exact same function, what that means is it is symmetric about the y-axis. Okay, that's the test, to like plug in f of negative x, just like that. Okay, number 2. Explain algebraically why the function has a domain of negative 1 to 1. Okay, so we just talked about how there's asymptotes at x equals negative 1 and x equals 1. What happens when x is greater than 1 or when x is less than negative 1? You can see if you put a really, just a little bit big number in there like 2, it'll be 1 minus 2 squared, which is 1 minus 4, which is negative 3. Is there a square root of negative 3? No, there's no real number that's the square root of negative 3. So any number bigger than 1 put into the denominator is going to create a square root of a negative number. So that is why the function has a domain of just negative 1 to 1 and nothing outside of that. Does it include negative 1 and 1? No. As we said, there's an asymptote at x equals 1 and x equals negative 1, so it does not include those points in the domain either. Find the exact area enclosed by the function in the x-axis, the y-axis, and the line x equals 1/2. So basically what they're doing is they're saying, okay, x equals y, the y-axis, the x-axis, the function itself, and x equals 1/2. So you're making a little box here, right? So it would look kind of like this. So the function looks kind of like that, right? It goes up to infinity at x equals negative 1, and so or x equals 1. And so what they're saying is y-axis, x-axis, x equals 1/2, and the function, find this area here, okay? And we can find that area by doing an integral from x equals 0 to x equals 1/2, which is the domain here, and then you plug in the function itself. I'm going to write it as a power because it's easier to take the integral of. So I'm going to put, I'm going to actually make this into in the numerator, so it's negative 1/2, right? And dx. So what does this remind you of? Actually, this is, the integral of this would be arc sine. So it would be arc sine of x, and you would evaluate from 0 to 1/2. And so I would put arc sine of 1/2 minus the arc sine of 0. Arc sine of 0 is just 0, right? Because the sine of 0 is 0. So what is the arc sine of 1/2? The arc sine of 1/2, let's see, what angle has a sine of 1/2? It would be like 30 degrees, right? Yeah, 30 degrees. So it would be like pi over 6 minus 0. So pi over 6. Let's move on to 22E.1. Find the volumes of the solids formed when the following are revolved through 2 pi about the y-axis. Y equals x squared between y equals 0 and y equals 4. Okay, so if I wanted to draw that, y equals x squared is a parabola. And if I wanted to draw y equals 0 and y equals 4, those are horizontal lines. So let's see. About the y-axis. So that means we're going to spin it around this way. Okay? So if we're going to spin it around that way, then we are going to slice it in the y direction. So this is why this is HL and not SL, because the integral is going to be with respect to y instead. So the limits of integration would be from 0 and 4, right? Y equals 0 to 4. And my function, I can't put y equals x squared in there because I need to have it in terms of y from the point of view of x. So instead of y equals x squared, I'm going to have like the square root of both sides. I'm going to have square root of y equals x, and square root of y is what I'm going to put in here. Okay. Now I'm ready almost. The only other thing I need to do is I actually need to make little discs out of this thing. So like each one of the discs is dy wide. Okay, so the width is dy of the disc, and the radius of each disc is square root of y. Okay, which is the distance in terms of y from the y-axis. So if I wanted to write the equation for the volume of the cylinder, I would put pi square root of y squared times dy. Okay, and square root of y squared is just y, right? So actually, if I put pi square root of y squared dy, and I integrate from 0 to 4, I actually am going to be integrating from 0 to 4 of pi y, because square root of y squared is just y. Okay, and now I'm going to take the integral of pi y. Pi is just a constant coefficient, so it's going to be pi y squared divided by 2, and I'm going to integrate from 0 to 4. So if I put 4 in there, it's going to be pi 16 over 2, and if I put 0 in there, it's 0. So basically, my answer is 8 pi. Let's look at C. Now I am going to be doing this for natural log of x. Natural log of x kind of looks like this, right? Intersects at 1 here. We're going to take the revolution between y equals 0 and y equals 2. So basically it's going to be kind of like this shape here, okay? And we're going to slice it into cylinders or discs like that. Each disc is going to have the equation pi times r, and the r here is going to be, let's see, I need the x value in terms of y. So y equals natural log of x. If I do e to the both sides, then I would have e to the y equals e to the natural log of x, which is just x. So actually, my radius would be e to the y. So e to the y squared, because pi r squared is the area of the cylinder, the area of the cross section, and then I multiply it times dy, which is the thickness of one of these discs. So then I'm going to integrate it from 0 to 2. So it's the integral of 0 to 2 of pi e 2y dy, right? And the integral of pi e to the 2y is just e to the 2y divided by 2 pi. Is that right? So if I take the derivative of that to check it, I do the chain rule, and then the 2 comes out, and it cancels out. So it's perfect, yes. Then I put 2 at 0 here. And then I'm going to substitute in 2 to my integrated function, and it'll be pi e to the 4th over 2. And then I put 0 in for the y, and it'll be pi e to the 0, which is pi times 1 divided by 2. So that would be minus pi over 2. So basically I got pi e to the 4th minus 1 divided by 2. Okay? Let's take a look at E. So in E, I graphed it up here. So in E, what they want you to do is they want you to rotate this shape here around the y-axis, and this was not obvious to me, but what they said in the solution was when they say x equals 1, what you're supposed to do is figure out the y point that corresponds to x equals 1, so that would be y equals 0, right? And then you put in x equals 3 in and see what the y coordinate that corresponds to that would be, which would be 3 minus 1, which is 2. 2 cubed is 8. And then you're going to use 0 and 8 for your limits of integration. And that was not obvious to me, so I thought that was pretty weird. But, okay. So basically you've got this shape here, and then you're going to spin that around, and you're going to make kind of like a bowl out of it, but the bowl is filled, okay? And they want to know the volume of that. So each one of these discs would have a radius of, and then we would take this and we'd solve for x. If we solve for x, it would be y cubed root plus 1 equals x, right? So this would be the radius that would be used in the integral. So the integral would be from y equals 0 to y equals 8, and it would be y cubed root plus 1 squared, because it's radius squared, times pi dy, okay? And then, to integrate this, I'm going to have to expand it with FOIL. So I would end up with y to the 2/3 plus 2y to the 1/3 plus 1 pi dy. And then I would want to take the integral of each term. So the integral of y to the 2/3 is going to be y to the 5/3 divided by 5/3 plus y to the 1/3 integrated is y to the 4/3 divided by 4/3 times 2. And then 1 integrated would be y. And then all these would be multiplied times pi. And I would substitute in 8 and 0 to see what would be the result. So that would be pi times, and 8 cubed root, remember, is 2. So 8 to the 5/3 is going to be 2 to the 5th, which is 32. So 3/5 times 32 plus 2 times 3/4 times y to the 4/3 would be 8 to the 4/3. 8 to the 3rd is 2. 2 to the 4th is 16. Plus, and then I would put in 8 for y, and then we get that. And then when I subtracted if I put 0 in for any of those terms, I just get 0. So I subtract 0, okay? And then now I'm going to try to simplify each one of these. So it would be pi times 3 times 32 is 96/5. 2 times 3 times 16 divided by 4 is 2 times 3 times 4, which is 24, plus 8, which is 32. And then I can simplify this. I can say 32 times 5, which is 150, plus 10 is 160. So I could add 160 to 96. That would give me 256 fifths pi. 256 fifths pi. So this would be my answer. Whew. Okay, number 9. This is going to be our last one for the page. We're going to find the volume of the solid of revolution formed by revolving this relation. X squared divided by 9 plus y squared divided by 16 equals 1, of course, is an ellipse. The ellipse is 3 wide and it is 4 tall from the origin. Okay, and so it would look kind of like, let's see, 3 wide, 4 tall. So it's kind of like taller than it is wide. And let's see, equals 1. So it's kind of like this. And then we're going to rotate it about the y-axis through 360 degrees. So it's kind of like this, like a little beehive, okay? And so basically, we need a expression with x on the left and everything else on the right. To do that, we would first subtract y squared divided by 16 from both sides. So it would be x squared divided by 9 equals 1 minus y squared divided by 16. Then I would multiply both sides by 9, so I would end up with x squared equals 9 minus 9/16 y squared. And then I would take the square root of both sides, so x equals the square root of 9 minus 9/16. So I could actually say that I could put the 9 on the outside. It would be 3. 1 minus y squared divided by 16. And then that would become my radius, okay? And I would integrate from, remember that this goes from -4 to 4 in the y direction, so my integral would be from -4 to 4. My x expression would be this squared, because it's the radius squared. So I would put 9 times 1 minus y squared divided by 16, I squared it, times pi dy. Okay, this doesn't look too bad to integrate. So then when I integrate this, it's going to be, I'm going to multiply out the 9 first, just so that I can make it a little easier to integrate. Let me get rid of that. 9 minus 9/16 y squared times pi dy. Now I'm going to integrate. So 9y minus 9/16 y cubed divided by 3. And I'm going to multiply everything by pi, and then I'm going to put the limits for -4. And so first, when I put 4 in there, I'm going to get pi times 36 minus 9/16, and 4 cubed is going to be 16 times 4 is 64 thirds, and then minus, and then I'm going to put in -4 in there. It's going to be -36 minus 9/16, and minus 4 cubed is going to be -64 divided by 3. And then let's try to simplify this. I'm going to simplify in a different color. So, for example, 16 canceled with 64 is going to be 4. 9 canceled with 3 is going to give me 3. So basically I have 36 minus 12 there, which is pi 24. And then here I've got 16 canceled with 64 leaves me 4. 3 canceled with 9 leaves me 3. So now I have -3 times -4, which is positive 12. Positive 12 minus 36 is -24 pi. And then minus that. So actually it's going to be pi 24 plus pi 24, which is going to be 48 pi.